Hello, I am Mr. Broom-Peltz. I'm over at the Tilton School in Tilton, New Hampshire, where I teach physics and pre-calculus. And today we're going to jump into one of my conceptual physics classes, where we are reviewing for an assessment on heat and temperature. And we do this today in a hypothesis-driven experiment about insulation and how we can stay warm even after we put our hands in cold ice water. So let's jump in.
My pinky's so frozen.
So what we have here today is we're trying to see if we can keep our hands in an ice bucket for a minute. And so what we have here is a bucket of snow.
I feel my fingers in it weird.
Yeah, they're probably freezing because the temperature in here is negative 10 degrees Celsius. The principal investigation that we're doing today is about insulation and seeing if we can make this experience a little more comfortable. Okay.
1, 2, 3.
How'd it go?
Oh my god. That's not fun.
Would it be bad if I did it again?
Yeah, you can take it out. Are your hands frozen yet?
I can do it.
As you can see, there's a lot of laughter, and I wanted to start off with a hands-on activity that was fun and relatable to a real-world experience to set the stage for the discussion about the concepts from the chapter, namely being heat, temperature, and in this case, how insulation can affect the rate at which heat is conducted from our body to a body of some really cold water. So in this next bit, the students are discussing which of the examples of insulation they think will be the best at keeping their hands warm, especially in comparison to not having anything. So we have five different methods. We have a little glove that's a little less full, more lard here, sand, styrofoam, packing peanuts. And so we're going to discuss right now which method will be able to keep us warmest in the water. So what do you guys think? What's your hypothesis?
Lard.
Lard. I think it's the lard. Okay. So what do you guys think? Lard. Think it's lard? Lard? I'm pretty sure it's lard? Okay. Which one do you think is going to do it? The big bag or the small bag? The big bag. You guys think the lard? You think the lard's going to work?
Yeah.
Okay. So we have our volunteer here. You now have fat hands.
Smushing.
Yeah, smush it all around.
That's gonna be under your fingernails.
Okay, so for comparison, maybe you should try putting both hands in to see which one feels colder. Okay? Okay, so 3, 2, 1, go.
It's not that cold.
It's not as bad.
Oh, I have lard on it.
Let's see. Yeah?
Yeah.
Isn't it probably easier to keep your left hand in?
Yeah.
Oh my god.
It's clearly much easier if your hand's in the lard glove. Okay,
Yeah, it's actually really warm.
Okay,
I don't want to take it out now.
take this. No, you got it. Now put both hands in. Ready?
Wait, what?
You have put both hands in so you can feel
No,
the.
I don't.
Yeah, you do. You got to be able to compare. How?
I already did the one.
No. Try both. Try both at the same time. You'll your facial reaction will be the tell. That's gonna be our metric.
Do it.
Okay, you got it. 3, 2, 1. Let's put them in. Yeah.
Yeah?
Notice any difference?
Yeah?
Yeah. Which one's a little more comfortable?
Lard.
Yeah, lard's pretty comfortable.
Yeah.
Those polar bears are onto
It's good
something.
stuff.
Yeah. So now try that one. Let's see if this works. Okay. How's that working?
I think the styrofoam's actually working a little bit better.
Okay. So let's come over here. What's happening, Ming? Walk us through. Tell me what's happening. How is this working? How is the lard and how is the styrofoam able to keep his hands warm?
Because, well, it's not directly like contact to the head. So first, the heat from the stuff like the gloves will like lose first. Wait a minute. Let me just. I don't know. Like I could do that.
So at this point, we went back to our seats to discuss what had happened. Namely, how we can use the kinetic theory of matter to better understand why styrofoam, for example, which is mostly air, would be a better insulator, or I guess you could also say worse conductor, than Crisco. So I learned a lot from this first experience and modified how the activity was presented to the class The video you saw was from the first class that I tried the activity with, but unfortunately, when I went to the second class, my phone was full, so I'll just report here what happened. In the other class, also not recorded, I started the energy off a little bit calmer. So one of my main critiques with the first round was, while the class was having fun playing with the ice, when encouraged to explain why one method worked better than the other, many of them struggled. So I wanted to make sure that the class had in mind the right questions, or kind of primed the pump so that we, as we started the day and played and learned. So in the second class, we spent more time developing how we were going to prove if one method was more effective than the other, without needing to rely on pain as a measuring device. So let me just justify that for a second, in that I think pain and physical strain can be a useful measurement tool, especially if it's well calibrated. But I just think an ideal scientific method relies on more objective measurements, and therefore learning how to combine both is, in my opinion, better. So before the second class came into the room, I had wrote a couple of questions on the board. Take out your notebooks and write your thoughts, questions, and answers for the following questions. 1, what is heat and how do we feel it? 2, consider the objects on the table, which included the tub of ice and the following: a Crisco glove, dirt bag, and foam. Which of them do you think will keep your hands warmest in a bucket of salty -10 degrees Celsius ice water? And then finally, how will we know what method works best? Describe a procedure for testing your guess and compare it to the other options. So students volunteered their answers and we discussed them. Then I offered an IR thermometer as a tool to be used. They'd seen it before, so they knew how to use it. And then after playing with the IR gun, we agreed that since it didn't seem to be very precise, that a change in temperature would be our best method for comparison, and kept it within 5–10% of each other. So that was about, as long as the measurements were about 3 degrees Celsius, we agreed that that was basically the same, because that's what the IR gun would fluctuate around. So our plan, as developed through this conversation, came out to be something as such. First, measure the students with the IR thermometer. It's really windy. Measure students' hands with the IR thermometer and put them in the ice bucket for 30 seconds. Remove the hands and then record the temperature change. Second, use this procedure for the following combinations: no glove on both hands to test if both hands lose heat at the same rate, then one hand in foam, one hand in dirt, and one hand in Crisco. Finally, calculate the temperature difference for each of the scenarios and compare them. This strategy, I found, was much more effective and efficient than having the class just start playing with the ice bucket, as evaluated by the duration of their engagement and the quality of their responses to conceptual questions. By putting the thing everyone wanted to do, which was put our hands in the ice bucket, on the other side of a critical thinking task, we were able to better motivate the play and then the learning. The thinking we need to do was consider what method we thought would work best, justify our guess using past experiences and theories we had learned, and then to figure out how we would be able to measure the difference. So I think that those aspects should exist in any sort of learning strategy like this. But another strategy I was considering in the future is having multiple buckets for students to experiment with separately. Although my initial hunch was having one group together would focus our efforts, I see the trade-off is that fewer students were able to physically doing the experiments, and so I wonder if that would promote engagement and critical thinking. So I plan on using a similar activity in the future and greatly appreciate feedback. I hope this video was helpful for anyone who is trying to promote similar student-centered experiential learning in their classes. Please, if you have any comments, leave them below, and thank you for watching.